Bro, we gotta fix that. We gotta fix that. Bro, that light is so glaring. What's up? What's up? What's up? What's up? What's up? I'm a I'm gonna give it a few minutes and let people start joining in. But how you been rocking with week two? Week oh, how you been liking week two so far? What's up? Learning a lot. Love to hear that. Went to the roasted resume event so far. Went to the roasted resume event so far. Okay. Um, have y'all been finding any problems with the week two questions? For this one though, I am going over. I know the title says week two review, but I hope y'all not mad. I'm gonna go over last week's project. Right. So last Friday when I did the live stream, I went and did contains duplicate. But a lot of feedback that we got was that going over the project will help people. So that's really what my focus is on. Um, that's what my focus is on for this week. I hope y'all not mad. And then next week, I'm gonna do the linked list implementation project. New feature, pre and post problems are good additions. And did you like the roast your resume? We'll take any and all feedback. So anything we got, I'd love to talk about it while we wait for people to join. Let me make sure I got VS Code. Oh yeah, it was fun. What's up, Teo? Hey, I'm glad y'all liked roast your resume. I feel like that's like a I feel like that's a good implementation. Being able to just be honest and straightforward and still keep it lighthearted, you know. We can make improvements and still keep it lighthearted. Let me make sure that I got all this stuff. Oh, VS Code. Actually, okay. Y'all give me like 30 seconds. I'm about to go refill this and then I'll be back. There we go. Okay, bet. So I'm gonna get started on going over this week's live stream. So I know on the title it says that it was supposed to be week two walkthrough, Just like last week, we did a week 1 walkthrough. But for this week, I'm going to actually change it up and do week 1's project. Because a lot of people have said that that would be beneficial to go over. And I think it just makes sense that now that week 1 is over, we can walk through the project. And then next week, I'm going to walk through this week's project, which is the linked list implementation. So hopefully that's okay with everybody. And then I can get started. Let me see, actually, because the starter code. Okay, share my screen. Okay, boom. Are y'all able to see my screen for the array list implementation? Let me just get a couple yeses or nos to make sure I can move on. Okay, bet that. So, okay, appreciate that. Okay, so y'all know, before we get right into the code, we have to talk about arrays and understanding arrays, right? Because if you just go straight into code, you're gonna mess yourself. So let's just walk through everything, and then as we're walking through everything, we'll get to see what we're doing, what it is that we're trying to build, and then see how to get to the end product. So the first thing that we want to do right here, it says initialize the array with an initial capacity and then do size. So this part we can do real quick because it's just telling us. So it's just self that capacity. And that'll be initial capacity. And then self data. And we'll have that as none times. Okay, so the init is pretty simple. We initialize the capacity, which we're given right here as 10. Boom. And I'll explain what initial capacity means in terms of arrays. And then initializing self that data. And right here, it's none. I'm also explaining that. And then self that size was already given to us. So self that capacity, what does that mean, right? So when you have an array, and the way an array works is it starts off with an initial capacity. So in your computer, in the memory, it is like, let me see, it's like a drawer, like a cabinet in the kitchen, right? So you look at your cabinet in your kitchen, it is set to a specific capacity. So it can only hold a certain amount of items in your kitchen cabinet, right? That's what the self that capacity is. So we're initializing it to be able to hold 10 items. So this cabinet starts off being able to hold 10 items. But the reason we need that self that capacity is because with arrays, once you start reaching the end of the capacity, it gets doubled. So when you see, oh, I'm at a point where I need more space because I have more items I need to fit in this cabinet, I need to create a bigger cabinet and then get rid of the old smaller cabinet. Now I have this bigger cabinet and I can fill it up with stuff, right? Then you again are about to fill up the cabinet again. So you need to double that cabinet into an even bigger cabinet, and then take the stuff in the old cabinet, put it in a new cabinet, and then get rid of the old cabinet. And you repeat that cycle over and over and over and over and over and over and over again, right? So technically we can initialize the capacity to anything, but it was our 10 was already given to us, so we're just going to stick with 10. But that's the thing about self-dat capacity, right? Just being able to dynamically grow and shrink. Well, not shrink, but dynamically grow. Self-dat data, what happens when you first, you see we have none, we have it at none, a list of no items. So it's an empty cabinet. Again, when you first build that cabinet, the cabinet is empty, right? There's nothing in there until you add something in it, whether that be salt, pepper, oregano, parsley, whatever. But first it starts off with none. But you have, so it's an empty cabinet that holds a certain amount of items, but at this point you have no amount of items. But the self-dat data is saying, okay, there are no items in here, but the amount that we could hold is self-dat capacity. And then self-dat size, it's initialized to 0. Why? When you first get that first initial cabinet, it's a size of 0, because the size just means how many items or elements are in the cabinet. So when you initialize the array, there's nothing in it, as you can see right here with the none. So it's an empty, it's a size 0. So that's what we do with initializing, right? I hope that makes sense for everybody. Yeah, I hope that makes sense. Give me a second. So now the next thing, so we'll get into add. My bad, my thing is glitching a little bit. So now we'll get into self-dat add. So remember, this is our original cabinet, right? So this is what's going on. Cabinet 0, 1, 3, 4, 5, 6, 7, 8, 9, 10. Just to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, boom. So this is our cabinet right here, as we've initialized right here. This is exactly the representation of this cabinet with its capacity, right? So capacity starts off equals 10, and then size is equal to 0. So that's what this represents right here, right? That's exactly what I was trying to say. And then as you can see, the data is no data, but there's no data in this cabinet, but there's 10 spaces there's space for 10 elements to be fit in there, right? So now when we think about adding to this cabinet that we have here, what is it that we want to do, right? So as you're trying to add to the cabinet, the first thing that you would want to check, right, is is there even space to put something in this cabinet, right? Because at first, when you just look at it and you see, oh, of course it's an empty cabinet, I'll just add something to it, add something to it, add something to it, right? But once you get over here and you filled it up all the way to the last spot, and then you're just adding to it, you're never actually checking if there is space to add something to it. Because what if there is no space and you're just cramming everything in there? You're going to get an error. So the first thing that we want to do is we want to check if there's enough space to add elements, right? So that's the first thing that we want to do. We want to check if there's enough space to add elements. If there is no space to add elements, what would you do at that point? You have to grow, you have to grow the cabinet. You have to build a bigger cabinet, right? So if there isn't enough space to add an item, we'll grow the cabinet. In this case, double it, right? We'll just double it just to make it easy, right? So the first thing that we do is we check if there's enough space to add to it. If not, we have to double it, or actually, let me say resize, because that'll come in later. So we have to resize the cabinet, right? Okay, boom. Now let's say we check, like in this case, and there is enough space to add to the cabinet. So boom. What do we want to do? We want to actually place the new element into the next available slot, right? So in this case right here, let's say we want to, so let me just write it down first. Place new element into the next available slot. So in this case right here, first what we do is there, let's say we want to add the number 7 to our list. So we're gonna say, or to our let's say pepper. We want to add pepper to the cabinet. So we have pepper. Let's just say we have pepper that we want to add, and we're trying to figure out where do we add pepper, right? So the first, or we want to add pepper, so we say, okay, I want to add pepper into our cabinet. What happens? The first thing I do is I check, is there enough space to add pepper? I go look and I say, oh, there's plenty of space to add pepper. Okay, cool. Now the next thing I do, okay, I place the new element into the next available slot. So I have to figure out where is the next available slot, right? Now, what is a good way to figure out where the next available slot is? Because we don't want to just place it anywhere, right? We have to know, is the available spot in the beginning? Is it in the middle? Is it at the end? What is it? Well, remember, size is equal to 0. Capacity is equal to 10. So size and capacity are two different things, right? So if size is keeping track of how many items are currently in the cabinet, then we can actually use that to figure out where to put the item in the cabinet. For example, if size is equal to 0, we can just put, remember, arrays are 0-based indexed, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? It's a 0-based index. 0-based index. Okay, boom. So it's a 0-based index, meaning this is the 0th spot, the first spot, second, all the way into the 9th spot. There are in total 10 items, but you start counting at 0, right? And we see with an empty cabinet, it has a size of 0. So if the size is getting tracked and it'll correlate as we add items, it'll correlate with the index, we can actually use that. Use size to correlate the index. Because if there's nothing here, that means the 0th spot is available. If there's one item, like let's say we have let me actually write it up here. Let's say we have salt in this spot, in spot 1. Try my best to try and draw things out so it's clear for people to see. So we have salt over on the 0th spot, and now we have a size of 1, right? So what does the size of 1 let me know? That the 1 index spot is available, right? So I can use size to correlate the empty slot. Okay, boom. So now I can use that, and then from there, so I figure out, I use the size to correlate the empty slot, and then after I've gotten the empty slot, I'll just add element to that slot. Element to empty slot. So boom, I add the element to the empty slot because there's 1 element. So boom, I have my pepper. Let's go back to the pepper example. So I have pepper, and I say, okay, is there enough space to add elements? Yes, there is, right? Because size is less than capacity. So boom, there's enough space. Now I want to place the element into the next available slot. Well, what is the next available slot? I see size is equal to 1. So the next available slot is 1, is the first index. So now I add element to the slot. So now I have salt here, and then, I have salt here, and then pepper here. Let me see. Boom. So now the first index has salt, the next index has pepper, and now that's we've added it. After we've added pepper into the list, or the array, my bad, what do we want to do? Well, we want to increase the size. Why? Because we need that. We got to know what the size, we got to keep track of the size and make sure it's updated. So increase size by +1, right? So we've increased size by +1. Again, we'll need that. And you see how now size is equal to 2, and what index is available as the next slot? It's index number 2. Now that's the next available slot. So you see how size, keeping track of size makes it easier to keep track of where to implement, where to add to. I hope that's making sense so far. Before I get into the code, is everybody understanding what I'm saying? And always feel free to ask questions too. Okay, bet that. So now all we're going to do is take this and literally just code that up line by line, right? And again, this way that I show, the way I show of going about these problems, you're going to see me repeat it week after week after week after week. How I start off by just understanding what is it that what is my goal, right? Like, what is the goal? And being able to picture that goal. Because once you can picture the goal and walk through it like I did here, then you can come up with the step by step, because you're just writing here. I'm literally just writing down what I'm doing. When I'm trying to add pepper or when I'm trying to add salt, I'm going, what's the first thing I do when I add salt? Okay, I do this. What's the next thing that I do right after this? Okay, if this condition is true, then I do that. And then after that, then I do this. Then I do this. Then I do this. Like, I'm just writing down step by step how I move through the picture. So that's why I'm gonna always emphasize it, that when in order to really understand what it is, try and draw it out and just walk through the drawing. It'll make everything so much easier for you. But because now once you get here, we can literally just take this. Oh shoot. I take that. Boom. So boom. First thing that I'll do is check if there's enough space to add the elements. Okay. We check if self that size is equal to self that capacity, like we talked about. If there isn't enough space, what do? We call on self that resize. We haven't created that yet, but it is resize is one of the functions that we're going to get to right here. Oh, shoot. I forgot the underscore. Self that resize, right? And boom. Actually, let me move this over here. There we go. Boom. So next thing that we do is we place the new element into an available slot. And how are we going to do that? We use size to correlate the empty slot. Okay. So self that data. And we're going to use self that size. And then boom. So remember, self that data is this. It's everything that is within the container, right? So we're saying, okay, we're going to take the cabinet, right? All this means right here is we take the cabinet, which is self that data, and then we'll take self that size or that underscore size. And then, so that's letting us know, okay, from this cabinet, we're putting it in this spot in the cabinet. And so that's the location that we're inserting. And what we're inserting is the element. Oh, shoot. Yeah, element. That's what it is. Boom. So we're inserting the element. And then after we've inserted the element, what does it say to do? Increase size by 1. Matter of fact, let me take this, put it up here. Yeah. And then boom, we'll do to self that underscore size plus equals 1. And we can get rid of pass. And just like that, we've created the add function. Now, with this array list, we are able to add to it, right? All because of being able to do this, right? Now, boom. Now, the next thing that we want to get to is insert, right? And you might ask, oh, what's the difference between adding and inserting? Well, it kind of gives you the answer right here. But as you see, when you add, you're just adding to the next available spot in the cabinet, right? But if you're inserting at a specific spot. So let's say I take my cabinet, Okay, boom. So I take my cabinet and let's say I still want to add pepper, but I want to add pepper into a certain spot, right? Like, let's say I had salt, paprika, and parsley, right? Let's add salt, paprika, and parsley. And then I have pepper. And let's say, okay, I already had salt, already had paprika, already had parsley. I just went to the store and bought pepper. But I know I use pepper more than I use paprika and more than I use parsley, right? So because I know that, I want pepper to go over here because I want it for quicker access, right? So I want it at this, and in this case, we'll have to remove one just to keep size the same. But now I want to add pepper. So I have my pepper at the front just because, yeah, whatever reason. I use pepper more often than paprika and parsley. So I want it at the second slide of my list, right? So, okay, now that we know that, boom. So how do we go about adding 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Okay, just making sure the list is still the right size. Okay, so now when it comes to adding the pepper, what's the first thing that we want to do, right? As you see here, the two things that it says we need is an index and an element. I explained why we need the index and element because, again, you might have pepper in front of paprika and parsley, right? But when you want to insert it to a specific spot, what are some caveats that could come with that, right? Like, let's say, I don't feel like typing everything out here, but just say this whole list is full. And that's what you always want to think about. Like, worst case scenario, let's say this whole cabinet is full. Or let's say actually this cabinet has a capacity of 10, but then somebody says, hey, put this pepper in the 12th spot. It's like, hold on, we don't have a 12 spot. That's going to cause an error, right? So we have to make sure that the first thing that we do is we check our index to make sure that it aligns with our capacity. So the index that we are given has to be less. We have to check if it has to be greater than 0 because there's no negative space, right? So it has to be greater than 0, and it also has to be less than capacity, right? It has to be greater than 0 and less than capacity. Then we know we can add it. So that's what we have to do and that's what we call being in bounds, right? Check if index is in bounds, meaning just to make it clear, index is greater than 0, so no negative spaces, and then make sure index is less than capacity, right? Okay, so boom. Actually, not even capacity. That's my bad. I meant size. I realize I've been saying capacity this whole time. Okay, boom. So size. And the reason it's size and not capacity. The idea is still the same when dealing with size rather than capacity. But when we work with the size and not the capacity is because the capacity is 10, right? But you can't just add like oregano right here, right? It won't make sense to just have these. It won't make sense to just have these just wide open, right? So that's why we use size, because size is going to make sure everything is in order. So it's not capacity, it's size. We have to make sure index is less than size. So that's what we call, that's how we check if everything is in bounds. Okay, boom. So now we've checked if everything is in bounds. What's the next thing that we have to do? Well, we have to make sure that there's enough space, right? Because now, now this is where capacity matters, right? Because if there's not enough, if we ran out of space, like if everything is filled up, then this is where we have to do this check again, where we're checking if there's enough space, right? So really, we can just copy this and then bring it down here because it's the same exact check, right? So we check if there's enough space to add elements. If there isn't enough space to add elements, then we resize, right? It's literally the exact same thing, right? And then, okay, boom. Now, the next thing that we do is, okay, we say I have, okay, now let's say I'm adding oregano. And okay, boom. So I want to add oregano, and I check if index is in bounds. Oregano, let's say oregano at index 1, right? So I want to add oregano. Let me boom, boom, boom. Boom. So I want to add oregano right over at index 1, right? So I want it to be oregano at index 1 would cause it to be the list to be salt, oregano, paprika, and parsley, right? That's how it's gonna be. And then boom, that. So this is what I want. I want oregano to be right here after salt and before paprika, right? What do you notice, right? So paprika used to be at index 1, but now it's at index 0, 1, 2. So what did paprika just do in order to create space for oregano? It went from spot 1 to spot 2. So it moved over by 1. And then let's check parsley. Parsley started off at index 2. But where is it now? 1, 0, 1, 2, 3. So parsley also got shifted over by 1 in order for me to create space at spot 1 for oregano. So what does that tell me about what I need to do next? That lets me know that I need to shift everything over by 1 because then it gives me that space to to add everything, right? So the next thing I do is shift everything over 1 position to the right. Right? So I have to just shift everything over 1 position to the right. And then that creates, let me actually keep a blank. So I shift everything over 1 position to the right. Then it gives me this space right here to add oregano. And then I add oregano. And then boom, right? So now that I have that space, I can add oregano. So, or in this case, insert element. Now that everything is shifted to the right, I can insert the element, right? And then again, it's after we've inserted the element, we know now that the size grows, right? Because we just added to it. So once we know that, we have to update the size, right? So increase size by +1. Boom. And from here, I can just take all this and I could just code it up, right? Boom. So now I will take that, copy, boom, boom. So first thing we do is we check if index is in bounds. So we'll say if index is less than 0 or index is greater than size, right? Because that's exactly what this tells us. If it's less than 0, if it's greater than 0, actually, yeah. Actually, I'm gonna write down what takes away. Check if index is in bounds. So in order for it, I hope this isn't too confusing. I'm writing what is considered in bounds, but with my check is checking for it being out of bounds. So it's almost like checking the opposite, but it's checking not the opposite necessarily, but like the inverse, right? So I'm checking if index is less than 0. So I'm checking if it's negative, which is this requirement. And then I'm checking if index is greater than self to at size, because those are the two things that will raise the error, right? And so in that point, we'll raise an index out of bounds error. Oh shoot. Index error, and we can just say index out of bounds. Just that's what it is. Boom. So we raise this error so we don't actually have a bug in our code. We can actually catch the error when it comes up. Now, okay, boom. So we've done that step. So the next thing that we want to code up is we want to check if there's enough space to add elements, right? And how did we say we're going to do that? It's literally, we're just going to resize the cabinet and double it if there isn't enough space. And again, we talked about that earlier. It's just this. So I can just copy that. And then paste it right here, right? Because it's the same, it's literally the same code that we just used to check if there's enough space to add to the elements, right? Now, boom. So now we want to shift everything over one position to the right. So this is the part that might be a little tricky, but if you think about it, we're going, so as we're trying to, let me so with the cabinet here, right? If I want to shift everything to the right, what is it that I'm exactly doing, right? Like, how am I starting? Where am I ending? Boom. So I know, okay, the range that I'm working with is not necessarily from front to back. I'm starting from back to front, right? I'm making my way. First, I have to start with parsley, move it over right. Then go to paprika, move it over right. Then, if need be, go to salt, move it over right. But in this case, it was just parsley and paprika in order for me to insert oregano, right? So I'm starting from the end of the list, or not necessarily even the end because the capacity is here, but I'm starting at the size, right? So I'm starting at the size, and then I'm making my way all the way into the index, right? And I'm going backwards. So I'm looping from the start of from the size and making my way backwards. So from index 3, because size is 3. So boom, and then 3 minus 1 is 2. Boom, and then move that over, and then and then I'm able to add oregano, right? So it's for each item, and this is in the range, like I said, we're starting with size, right? And then we're ending off at index, and then we're just counting down by 1, right? And then from there, we can just remember data is the cabinet, right? That data is the cabinet, and that's at the position of the item. And we're going to insert to data this whatever is in, oh shoot, my bad, I'm trying to type and talk at the same time. It's kind of, yeah, but so data is cabinet. So we're taking that item and then moving it over, right? That's all that this is doing. We're taking that item and we're just shifting it into a new position, right? Okay, boom. Now we want to insert the element, which, remember, we've done that up here. Check if there's no something data, add element to empty slot. Well, actually, nah, it's not that code because we're using the index, not, okay. So I can't copy that because we're not using the size. We're using the in. So I was about to copy that code because I was like, oh, we've already inserted element. But the reason I didn't get that is because in the case of adding, you're inserting based on size, right? You're using the size to add to the end of the element. So I can't reuse this code because here we're inserting based on the given element the given index. We're inserting at a specific index, not just the end. So cannot reuse that code, but again, it's so we've shifted everything over one position, and then now at the index position, we'll add element. Boom. And then after we've done that, remember, we have to keep size consistent. So we increase it by 1. Boom. So that's how insert works. That's how add works. And again, the difference between adding and inserting with an array is that adding specifically adds to the end of the array. Inserting, you add to a specific spot, meaning which includes shifting over the other elements. Please explain the last line again. I don't know if that was a recent comment, but okay. So I'm gonna just reiterate everything that I said just to make sure I don't miss anything and everything makes sense to everybody. So first thing I'm doing, I check if index is within bounds. What does within bounds means? It means that it's between 0 and is less than the size, right? Just like here, index 0 is the beginning of the array. So if you say put it at index number 1 or index -5, technically that does mean something, but that's not the focus for this project, because index -5 would just put it 1, 2, 3, 4, 5. It'll put it right here. It'll put it in this spot right here, but that's not really what we're focused on right now. So yeah, in this example, we're just gonna make sure that the index that we're given is not less than 0 and it's not greater than our current size. If any of those are true, we raise an index error, right? Then the next thing we do is we check if there's enough space to add elements, right? So we're just checking the size to see if it equals capacity. Because if size equals capacity, it's a full cabinet and we need to resize by doubling. We shift everything over to the position to the right. So for each item in the range of self that size, so from whatever number self that size is, for example, in this cabinet, it's 3, right? So it's 3. So from 3, which would be index, so from index 3, which is here, right? That's the empty spot. Why? Because we have to get that and then move everything over there, right? So we're starting from size and then we're making our way all the way to the index that we want to actually insert it at. Because once we get to the index we want to insert, we don't need to go any further. We already got to where we wanted to go, and then we're going to insert. And then from here, we're just going to shift everything by 1, right? And then once we've shifted everything and we're at our index, once we've shifted everything and we freed up our index, or we freed up that space in the cabinet, then we can insert the element into that space, into that index that's now open. And once we've added something to our cabinet, then we have to increase the size by 1 because we've added 1 element to our cabinet. Okay. So now the next thing that we'll get to is talking about getting or retrievals, right? Because you can add and now you can insert. But what if you want to check if if there's paprika in the cabinet, right? What do you have to do in that situation? Let me bring this back down. Bring this back down. Okay, boom. Okay. So if all I want to do in this situation is I want to check if there's something in index number 1, right? This is what the get function gives you. You're checking if there's something in spot 1 and you want to check what that item is, right? So maybe in terms of your cabinet, let's say spot 1 is always for paprika, right? So you're like, okay, I want to get paprika from spot 1, right? And now, boom. What do you do once you want to? What do you do when you're trying to do that? The first thing that you do is, if I want to get something from this index, what do I have to do again? Like we talked about earlier, you have to check to make sure that that index is in range, right? Check to make sure index is in bounds. And we've talked about that, so I can just move on. Boom. And then let me just, so boom, raise error. If check to make sure index is in bounds, if not, raise error. Raise error. Boom, we've spoken on that. Boom. So now, once you've checked and there is no error, that index is available to check, all we have to do is return whatever data or whatever element is in that index. Return element in index. And look, because everything is stored in a list, all we have to do is just call it up. So this is like the get one is like the easiest. The get and size are the easiest ones. My bad. I'm over here getting lost. They all looking the same. Okay, so we'll just return element in index, and to do so, we'll just index the list. So retrieve the element at so check to make sure index is out of bounds. We already have code for that. So instead of retyping, I'm just gonna copy this one from up here. Copy that. Boom. Whoops. I meant to do it over here. Boom. Now, now we just return element. Return element. And literally that's just return self and just at index, right? That's it. So we check to make sure the index is in bounds. And then from there, we just return the element. We just return whatever is in that index. So get, as you can see, it's literally so simple, right? Now, after get, we have remove. Actually, before I do remove, and because I see that we have remove, we have size, we have is empty, and then we have resize, right? And doing get kind of made me realize that we can do size and we can do is empty. We can do these two literally right now, right? Because it's just as easy as get, right? So with size, if we're keeping track of the current size, like with the cabinet, if on your cabinet you have your size written on, your size is written on the cabinet. So once you, as you can see with up here with our inits, right? We have size that's written in our cabinets. We have our data, and then we have capacity. So we know we can get size, right? So when it comes to getting the size, if we already have access to the size, then we just have to return size, right? Boom. And if y'all notice, we have, for this function name, we have size. And then for the initialization, we have underscore size, right? And that's just to make sure that the method doesn't get confused. Just so when you call the function, it actually calls the function, and it doesn't change all of that. It's just to make sure things are consistent. And yeah, but you see, with this, we already know what size is, so we don't even have to do too much to return the size. We already know what it is. All we want to do is print it out. So that's how we'll just print it out or return it, right? And then for is empty, when it comes to is empty, what are you checking? How do you know something is empty? Well, if the size is 0, that automatically tells us that it's empty. If the size is not 0, it can't be negative, right? Because with the with adding to it, where it can't be every time we add it with the index, or actually with insert, every time with the indexes, we're always checking to make sure that it's in bounds, right? So that means there is no negative, right? So it can either be 0 or it can be greater than 0, If it's 0, it's empty. If it's greater than 0, it's not empty, right? So we don't even have to do too much on this one. We can simply just check if it's empty, and then we'll just return true or return false, right? So return that size equals 0. Oh shoot. Return self that size equals 0. Literally that. We'll check if self that size is equal to 0. That'll either give us true or false. Because all it's checking, is it true that self that underscore size is equal to 0? If it's true, return true. If it's false, return false. And the reason we're checking specifically this and not if it's greater is because this function is asking if it is empty. So if it's equal to 0, if size is equal to 0, that means it is empty. So we return true. True if empty. True for empty. Return false for not empty. Yeah. So boom. So we've been able to just get out size, and we've been able to get is empty just because of how quick it is. So now I'll make sure. Okay, boom. Oh, all that is making sense so far. Boom. Now let's talk about removing elements from the array, right? Now, when you want to remove an element from the array, there's a few things that you want to be paying attention to, right? You want to pay attention to, it's almost like inserting into the array, right? When you have, let me bring that cabinet again. Bring that cabinet again. Boom. So we have our cabinet again. And let's say I want to remove paprika, right? What do I have to do in order to remove paprika? Well, first, I would take paprika out, right? Because I know, okay, paprika is an index 1. I'll take out paprika, and now we have this. And then from here, I have to move parsley over to where paprika used to be. Boom. And then change this. I update the size to 1 less because we just removed something, right? So to write that down. So the first thing that I want to do again, so as I see here, I'm getting the index. So as I'm getting the index, first thing that I'm doing, checking if index is in bounds. Boom. So we first check if index is in bounds, right? Then after we've checked if index is in bounds, we want to keep track of what it is that we're removing. Keep track of what is removed. Then we'll remove from end because so let me get back to having paprika right here because I didn't necessarily show that too well. Okay, so yes, when paprika goes away, we'll just shift parsley over. But in order to shift parsley over, we'll copy what is in parsley, right? That's what I mean by keep track of what is removed, because paprika has been removed, but we don't need to keep track of paprika itself. It's more so that we're removing parsley from here in order to shift it over, right? So we'll remove paprika first. Hold on. So first we'll remove the index spot. We'll remove element in the given index, right? And then we're gonna have to, after we remove the element from the given index, then we're gonna have to shift everything to the left. So almost shift everything to left. And then we're gonna update the size, which we've spoke about because we have to update the size right here. Boom. Just to make sure I got everything. So if I want to remove parsley, I take out parsley, I take that, and I shift it over 1, and I shift everything at the end 1. Boom. Then I update the size. Oh, that's right. Okay. So as we're removing, as we're shifting everything to the left, there's gonna be one more thing because we're just like when we were inserting. So we're gonna have to, when we're shifting everything, we're copying from one thing and then adding, we're copying from here and adding over. But the thing at this side, or I guess since it's backwards for y'all, so but we're copying from here and shifting it over here. So taking whatever was copied from here and shifting it over here. But by the time we get to the end, the last two things are the same because of that copy. So we always got to make sure that we're getting rid of the last thing. So for example, when I have paprika here, because as we're coding it up, in order for us to know what is in spot index 2 to put in index 1, I have to first copy parsley into here, right? And once I do that and I'm at the end, there's duplicates, right? So then I have to remove the duplicate. So shift everything to the left. I almost forgot about that. See, that would have had an error. And then remove duplicate. Okay, so we're checking if index is in bounds. We're removing element, shift everything to the left, remove the duplicate, and then we'll update the size, right? And then I don't think we have to return anything. This one is just boom, boom. So first thing we do, check if index is in bounds. We wrote code for that already. So I'm gonna just copy and paste it again. Copy and paste the code here. Boom. So that's the first thing we do. We check if index is in bounds. If it is, we'll remove the element from the given index. Okay. So up front map remove. Then index. set that equal to none. Okay, boom. So we remove element in the given position. And then next thing we do is we shift everything to the left. And that'll be for range. So that size minus 1. That data at I. And we'll set that equal to self that data at I plus 1. And then next thing we do is we update size. Size. This time we're reducing it. Okay, so boom. Remove the element at the specific index. Okay, boom. So we check if index is in bounds, then we remove the element if it is in bounds, and then we shift everything over. Oh, shoot. I forgot to remove duplicate. My bad. My bad. So to remove duplicate, we're gonna get from the end. We're gonna get from the end of the cabinet, and then we'll just remove it by setting it to none. Okay, and that should be everything. So check index, remove element, shift everything to the left, remove duplicate, and then update size. Okay, boom. So now we have size. Okay. Now, also, I thought if we shift elements to the left, everything just moves. Why is the last element in the container duplicating itself? Okay, so the reason everything is just moving or things are getting duplicated is because we're not necessarily in this. Where is it? Okay, so if I have, let me bring my cabinet down here again, just so I don't have to keep scrolling. So this is what I'm trying to do here, right? Boom. And let me just fill it up with more items. Let's say we have water. Let's say we have what else? Honey. Okay. We have water in the cabinet. We have honey in the cabinet. We have parsley. We have salt, right? So what we're doing here is we're saying, okay, well, first, we've already removed parsley, right? So this is what we have. We have salt, blank, water, and honey, right? What we're doing here is we're saying, okay, oh, shoot. Item. Okay, so what we're saying here is at the index that we're at, right? We are taking that item at that index. So if we're at water and if we're at the index for water and we want to get it over here, we're taking whatever is at this index and then we're moving it over. Add a plus 1. Wait. Self that data item. So oh, right. Yeah, because we're going that way. So plus 1. Okay, so boom. If we have water and we want to get water in here, what this does is it copies water and then it just places it right here. Boom. So essentially, this is what you're seeing. This is what the computer now sees at this point, right? So boom, now that's done. Now it moves on and then it copies honey, right? And then it just places honey right here, right? And this is what the computer is seeing, right? When you're done with this loop, this is exactly what the cabinet looks like. It's salt, water, honey, honey. So now we have to get rid of this last honey. And that's what this does. So now this last honey that we set it to none, it looks like that. That's why there's a duplicate, because it's getting copied. Because you have to think, when you have a real cabinet, you can just take your hand and you can shift it over, right? But when you're coding it up, you can't just put your hand in the program. The computer can't just put his hand there and then just slide it over. Now it has to take the data from here and then it has to copy that data from here, paste it over here, and then get rid of the original one. But it's still the same data, it's just copied, right? It just drops the original, but it's a one-to-one copy that it's putting over here. So now you have two copies of this, you have two versions of the same thing, and you don't need both. You just need it placed right here, right? So I hope that makes sense. Let me see. And then for resize, okay. For resize, this is where it's about the capacity, right? This is when the capacity comes in. Or actually, let me highlight this. This is when capacity comes in when it comes to resizing. As we talked about when we did adding and inserting, what do we check if we have enough space, right? And we do so by checking the size and the capacity, right? If size is equal to capacity, that means all the space in the cabinet has been filled, right? If size equals capacity, all the space in the cabinet has been filled. So now we have to resize or just build a bigger cabinet and double the space, right? So that's literally all we're going to be doing in resize. That just doubles the space just because we need it for when we're adding and inserting, right? So in order to double the space, what are the things that we need? Okay, well, first we know we have our current capacity, and just to store that, we're going to just store the double of our current capacity, right? Because we just need to know that. We got to know what is our current capacity just so we can double it, right? Then after we do that, we want to create a new array or a new list. Just like we initialized self.data right here, we're initializing a new self.data. That's what goes on under the hood when an array resizes. It's creating a brand new array or a brand new list, and you're just making a brand new cabinet. Then so we're gonna create a new cabinet, create a new list with the capacity of double current capacity. So in order for us to resize the cabinet, we have to take the measurements of the current cabinet and double it. And now we can build this new cabinet, which is double the size of the old cabinet, right? And then once we've doubled the size of the old cabinet, now we can take everything from the old cabinet and then put it into the new cabinet, right? And then from there, we can just set self.data. So we can set self that data up here to equal the new cabinet. So meaning that the memory space for where self that data currently is pointing to, it'll now be pointing to this new cabinet that we built. And then the computer would know, okay, we don't use this old self that data anymore. So it'll, over time, as you're using your computer, it'll end up overriding that because it sees that you don't use it anymore. That's the same way when you're on your phone and you delete pictures or videos, it doesn't just like vanish, right? The pictures and videos are still on your phone even after they're taken off of recently deleted. That's why it's possible to actually recover deleted photos even out like even outside of recently deleted. So if you delete and then you go delete from recently deleted, you can still technically recover that video or that picture because it's still there in data. It just doesn't have something pointing to it, right? So to you, it's shown as deleted, but under the hood, like under the phone, it just doesn't have anything pointing to it. So there's no way for the computer to actually know how to get to it because it doesn't have the memory address of that photo or of that video that was deleted, right? But it technically still is in there. Now, what happens though is your phone knows that, okay, this data isn't being used. So if you end up taking a new video, it would use the data that stored that space from the old data to 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 override that, right? So it's just adding it on top of it, and then because now that data gets used up by the new data, then that's how it gets used, right? So that's why even if you check your like phone storage and see how much phone storage you have, yeah, it's I really hope that makes sense. But that's why yeah, just that. I saw that they didn't have to remove a duplicate. And so I thought we returned the element that was removed. Oh, do we return the element that was removed? I mean, my bad. I can add that real quick. That's a good catch if we had to. I'm gonna just do it just in case. Self that data equals none. So I'm gonna have remove is equal to self that data. Self that data index, and then so we'll have that, and then we'll return removed. Boom. Okay. Yeah, so we'll keep track of removed and then we'll return removed. My bad, y'all. That's on me. Great call out, though. I very much appreciate that. Oh, dang. I wish there was a way for me to heart that comment. Okay. So now when it comes to resizing, so we double the current capacity. We create a new list with the capacity of double the current capacity. And then when we create that new list, then we set the new array, the new data to be equal that. So we're going to create a new list, and which would be length, new list with the length of capacity, new list with length of capacity. So we double the current capacity, create a new list with the capacity. Oh, shoot. I already said that. I'm tripping. My bad. And then we're going to, so now that we created this new list, we're going to copy everything to the new list. Copy everything to the new list. And then once we've copied everything to the new list, we'll set data to equal the new list, right? So we double the capacity that the new cabinet is going to be. Now that we know what the new capacity is, we create a new cabinet with that capacity. With that new cabinet, we copy everything to the new cabinet, and then we'll set data to equal the new cabinet. So now that we have everything that we need for our code, now that we have everything, so we're going to double the capacity double self that capacity. Boom. Then create a new list. We're going to create the new list with the capacity of double. Okay. So new list is, or I guess new array. My bad. I'm in Python, so I said list. And just like we did initializing, we're just going to create that. And then it would be double. It would be, yeah, we're just going to create that. Boom. So in this point, we're just redoing this, right? We're just updating this up here. That's all that we're doing. Oh, okay, we're down here. And then we're going to copy everything. So for item and range size. So no array at item. We'll have that sensor data at item. Boom. And then we're just going to have data be pointed to our new array. Since we don't need the old array anymore. And then I believe that should be everything with resizing. And with that, 23 out of 30 test cases. Am I missing something? Doing error for input validation, but it doesn't. It's not running because I hit it. Okay. Index error not raised. Where did I not raise the index error? Add. Hold on, let me look through this real quick to see.
Capacity.
Give me a second, y'all. I just gotta double check everything. What the... Insert. Index. Is it that? Index out of bounds. Is that what it's supposed to be? Wait, did I have it lowercase? Was that why it was? Oh, it was lowercase. Okay, that's my bad. Yep, that's exactly okay. Yeah. Okay, let's see now. Index error not raised. Is it still spelled wrong? Let me see if it's spelled wrong for these. Yeah, that is we're gonna add that aspect where it shows the specific part, like the line number. That's definitely facts. If index, and you checked index error under different methods. Okay, yeah. Okay, so raise index error. Am I not spelling it right? INDEX. Let me. Okay, let me copy that. Maybe I'm spelling it wrong. Copy. Okay, got me. INDEXERROR. Yeah. INDEXERROR. Where else would I? So there, it's spelled correctly. INDEXERROR. Raise INDEXE. No, so remove. Let me see if I type in index error. Index error. Index error. Okay, all index errors. Five index error conditions. The test expected to come to throw an error. Mm. It's less than 0. Okay, let me check the conditions because maybe it's the conditions. Okay. Yo, why is my thing lagging so much right now? Jeez. Why are we lagging? Why are we lagging? Yeah, what part of my get index is less than 0. Index is greater than self that size. Raise index error index pause. Spell index right. INDEX lowercase I. Index is less than 0 or index is greater than 10. Raise INDEX error. Let me see if it's because it shouldn't matter. This one. Yeah, that shouldn't change anything. Wait. Equal to. Okay, I think I figured out what the issue was. At first, I didn't spell index error right because I had a lowercase e. And then I think as I'm checking it to size, Yeah, I didn't do greater than or equal to. Let me see. Okay, so there's two. That's exactly what it was. Okay. Okay. That's just me typing too fast. My bad. My bad. My thing is lagging. Okay. So I just updated. So my MacBook is lagging a lot right now. I think it's okay. Yeah, it's getting hot. So my yeah, he stands there. I think I saw something. Um. Okay. Yeah. So the issue was that I was checking. I had so the two issues that I had were these. I was checking if the index is greater than self that size, but I wasn't checking if it was also great if it was greater than or equal to. So I had that error. And then the other error that I had was that I had this instead of this. So those are my two mistakes. But overall, I hope that was beneficial, at least the walkthrough. I know we had a little lag for the last 5 or 10 minutes as I was trying to figure it out. But I do hope y'all were able to still see the process of just figuring out these questions and being able to get to the code. Because the one thing that I want to stress to everybody is the process of getting to the code, right? I don't want because it's not just about just code, just hurrying up and trying to get some code. It's you have to know what you are about to code. And if you just picture it out as best as you can, sometimes I'll draw it out. That's so I have my notebook, pen, so I'll draw it out on a piece of paper, or I have my whiteboard in the other room if I don't feel like just using up so much paper. Like I'll get on the whiteboard and I'll draw it out and literally try and move with the drawing, or I'll even get like a physical thing. Like I can get this box to represent my array, and then this would be my fixed size. And I'll just try and picture everything that it is that I'll picture everything that it is, and then go step by step with every write down the first step that I have to do, and then write down the next step, and then write down the next step, and write down the next step. Right, because when I'm actually seeing myself doing it, and I see myself doing it with multiple examples, whether that be um with the array implementation, the data structure implementations, or whether that be with with like the coding questions, right? If you can just picture it with it, or if you're in an interview, that's then the reason I don't use the physical materials is because if you're in an interview, it might be tough for you to get access to physical materials, right? So I just want y'all to be able to see how I'm picturing it as best as I can on how I would do it in an actual interview, right? Because not only does it help you stay focused and help you stay on track, but as you're able to show the person interviewing you, you're able to show them your thought process and they can see it, right? Because if you just go straight to code, it's hard for them to follow what you're saying, right? Because now they're trying to pay attention to what you're saying and they're trying to pay attention to your code, right? And then after a while, it gets messy, right? So when you're able to picture what you're saying, the interviewer can see what you're talking about and be like, "Oh, okay." That's why I emphasize the cabinet examples. That's why I do it. I did it with every single one because that's how you got to talk to the interviewer so they can see and hear your thought process, right? And then it's beneficial for both parties. And then now when you have your thought process and you've pictured it, you write it down step by step, the ifs, the else's, what to do in each situation, as you would do in your real examples, right? And then from there, you just take that and then you just code it up. Because now that you have everything, it's so much easier to code up because you know how to code. You know the fundamentals of coding. You know about lists and indexes and functions and loops. So you know those things about code, right? So the coding part isn't the issue. The issue is more so coming up with what to code. So since that's the issue, that's always going to be my main focus is the process of coming up with what to code. You feel me? Because that's what the interviewers look for. That's what they care about is that process. Exactly. So I hope y'all enjoyed this week's run through. If y'all have any questions, because I know I've held y'all a little longer than it was supposed to, like 15 minutes overboard. It was planned until 9:30. So my bad for that. Hope y'all enjoyed it still though. I hope it was insightful. If you have any questions, I'll stay like a minute or two just to see if anybody has any questions. If not, oh, join the Discord. Is everybody on Discord? Let me get the Discord link for y'all while I wait to see if you have questions. I should have done that in the beginning. Okay, so I got the Discord link right there. So join up on Discord if you're not already. And with that, I will see y'all next week.